IB Physics M2025 Time Zone 2 SL Paper 1A Question 6. An object of mass 5 kilograms is initially at rest. An impulse of 2 Newton seconds acts on the object. What is the final kinetic energy of the object? Alright, so notice that I highlighted initially at rest. I did that because it tells us a key bit of information, that the initial velocity is equal to 0. Then the question is asking us to find the final kinetic energy. And to do that, we need the final velocity. Because what is the formula for kinetic energy? Well, recall that that is 1/2 mv squared. And in our case, we want the final kinetic energy. So we need the final velocity and the final mass. Well, the mass is staying constant at 5, so we only really need to find the final velocity, and then we'll have the answer to our question. So how do we actually find the final velocity, though? We need to get from impulse to final velocity somehow. And what is impulse? Impulse is the change in momentum. And well, what is momentum? Momentum is mass times velocity. So the change in momentum is the change in mass times velocity. And I was saying earlier that the mass is constant. So we have mass times the change in velocity. And the change in velocity can also be written as the final velocity minus the initial velocity. And we're given that the impulse is 2 Newton seconds. So we can solve for final velocity. Substituting 5 kilograms in for m, and our 0 for our initial velocity, we get that the final velocity is 2 divided by 5. Or in other words, 0.4. So let's substitute that back into our kinetic energy equation. And 0.4 squared is 0.16. 0.16 times half of 5 is 0.40. And this is joules. So our answer is answer choice A.